Good morning, Mr. Herman here with another video on similarity. So we talked about similarity already. Now we're going to go to triangle similarity. A bit more specific, we're going to get to proofs soon. And so we need to build up that proof toolkit as we're working through proofs later this year. So just like triangle congruency theorems, we had a bunch of S's, some A's as well. We have the same thing for triangle similarity. So let's go ahead and remind ourselves of what A means. So A is angles are congruent. All right. And S, in this case, it's a bit different. S is sides are proportional. Okay. So it used to be that sides were congruent. Now we're looking at sides are proportional. So we got to review some definitions that we saw last year in Math 1. And so we'll review those kind of quickly here. We have an angle bisector. So bisector means cuts in half. So a line segment that splits an angle in half. So I have an angle here. I'm going to draw. Here's my angle bisector. This angle right here and this angle right here are both congruent to each other. Okay? So that's how we have an angle bisector. Makes two congruent angles. Okay? So let's make a note there. Makes two congruent angles. The reflexive properties. The reflexive property was one of our harder properties to remember, because we would see it, but we were like, why do I have to say it there? So it's when a side or angle is congruent to itself. Okay, so in this case, I'll use a different color here. Angle H here is in the small triangle, HLI. It's also in the big triangle, HKJ. Okay, so we would say that angle LHI is congruent to angle KHJ. So it's congruent to itself, but we have to say it, because when we get to proofs, if we haven't said it, then we don't know that it's true. And that's the reflexive property. Corresponding angles. So we have corresponding angles if they're in the same position on two parallel lines cut by a transversal. So we have two parallel lines cut by a transversal, and we want to find corresponding angles. So that would be this angle right here and this angle right here are corresponding. Top right corner, top right corner. Okay, and those are going to be congruent. Let's look down to our vertical angles. So in our vertical angles, we have angles that are across from a vertex are going to be congruent. Okay, so in this case, we have 4 and 2 are across from each other. So we could write angle 4 is congruent to angle 2 because of vertical angles. You can also say that angle 1 is congruent to angle 3. Notice how I used 2 marks on these angles and 1 mark on these 2 angles. 1 mark angles are congruent and 2 mark angles are congruent. And then let's look at our alternate interior angles, our last little definition before we get into our new material. Alternate interior angles are inside two parallel lines. Okay, so we have two parallel lines again, AB and CD are parallel, and they're on opposite sides of the transversal. So EF, this line cutting in half, that's the transversal. So I'm going to say that this angle right here and this angle right here are congruent. They both have 1 mark on them. We could also say that these angles are congruent too. Okay, so this is what we're going to call our, these are our reasons that we'll see when we make our proofs. And so this is kind of our toolkit. So make sure you keep this sheet handy, because it's going to be very important when we start doing proofs later on this month and later on this year. So with similarity, we have a few different ways that we can show that triangles are similar. Our first way of showing that is through side, side, side similarity. Okay, so that one's kind of straightforward because all pairs of sides have to be proportional. So if I'm looking through these two triangles here, Think back to when we did dilation. So AB over DE equals 12 over 6, which is 2. So AB, DE, those are corresponding sides, and they have a proportion of 2, a scale factor of 2. Let's look at BC and EF. That's 16 over 8 equals 2. And then AC and DF are the last two. So AC over DF equals 18 over 9, which equals 2. And since they're all the same, we have similar triangles. You must check all pairs of sides. Okay, must check all pairs of sides. Okay, now I'm going to write a similarity statement here. So triangle ABC, I went left, top, right, is similar to left, top, right, triangle DEF. Okay, I had to have the same order because those parts correspond with one another. Now, we've got another triangle similarity reason, and that's going to be side, angle, side similarity. Okay, so we know that this angle here and this angle here, so angle ABE is congruent to angle DBC. Our toolkit's coming in handy already because these angles are across from each other. Remember, angles across from each other we call vertical angles. All right, since they're across each other, they're vertical angles, so we need to show that we say that they are congruent. I'll put that in parentheses off to the side, vertical angles. Now, we need to show our sides are proportional. Notice how our pairs of sides are next to our angle with our angle in between it. So we have BE over BC. It's 36 over 24, and that equals 1.5. And then we have AB over DB is 27 over 18, which is also 1.5. Okay, so now we have a pair of sides is proportional, another pair of sides is proportional, and the angle in between them is congruent. So we once again have another triangle similarity statement. We need to make sure we stick with our corresponding parts. So I'll have EBA is similar to triangle. Now this one's tricky because EB and CB correspond, so I have to start up here with CBD. Okay? So we've got two triangle similarity reasons so far, and we have one more. You know, say, Mr. Herman, we have a lot more congruency ones. So I'm like, we do, but there's something special about similarity because with triangles, we only need to show that two angles are congruent. Because triangles only have 180 degrees, if we know two angles, we can always find the third angle. And we know similar figures have congruent angles. So let's go and look through this one. There's a few things that we can do here on showing that this pair of triangles is similar. So the first thing we have to realize is there are two triangles here. Okay, so we have one triangle right there, and we have a second triangle, which is our bigger triangle. Okay, so those are the two triangles. When I look at these two triangles, I see, oh, well, angle S is in both triangles. So I know angle S is going to be congruent to angle S. And that is our reflexive property. Okay? Now, we have parallel lines here. If I have parallel lines, that means I can get corresponding angles. Okay, so my corresponding angles are in the same position. So I'm going to go ahead and mark this angle right here. So here's my parallel line and my transversal. So the top left corner, and down here as well, top left corner, parallel line, transversal, top left corner. So I can say that angle GHS is congruent to angle RQS, and that is corresponding angles. Okay? Now, since I know two angles already, I'm good to go. We could also show that angle SGH, this angle right here, is congruent to angle SRQ, this angle right here. Okay, those would also be corresponding angles. So I have two similar triangles, so let's write a similarity statement. So I have the small triangle is SGH is similar to triangle SRQ to get our last similarity reason. So we have fewer similarity statements because just two angles is good. So AAS is only AA. ASA is also only AA. And so that cuts down on some of the reasons that we have. So let's go ahead and apply what we've got. Do a little bit of practice. So are these pairs of triangles similar? Why or why not? Okay. So I'm going to go ahead and since I've got some numbers here, I'm going to go and check my numbers. Okay. So I've got my long side, so 29 over 10. That's going to be 2.9. And then I've also got 17 over 6, which is, what is that, 2.83. And since those are not equal proportions, not similar triangles. Okay? Since we don't have equal proportions, we don't have similar triangles. So let's take a look here, number 2. On number 2, we've got some vertical angles going on here. So I have one pair of angles congruent since those both have one marking, V and C. U, those are vertical angles. Okay, I'll mark that vertical angles. So we have two pairs of angles. So yeah, we have angle similarity. So we have triangle UVW. We want to start at U again. We want to go towards where the V is congruent, so UCD. All right, we'll take a look at two more before we're off to our exit slip. All right, so this one looks similar to what we just saw a little bit ago. We've got parallel lines here, which means that we have these two angles are corresponding. They're both in this sort of like top area. And then we also know that we've got these angles at L and R, which are in the bottom left area. Those are also congruent, but also because of corresponding angles. Okay, notice how I used one marking for these angles and two markings for these angles. And so we have angle similarity. Okay, so we start with Q, R, S. So we'll start with Q again, and then we go over to L and M. Okay, we got one last problem here. What's the angle measures? So if I have 56 degrees here and 60 degrees here, I am not going to have parallel lines. Okay, so no parallel lines here means no congruent angles. Okay, so J is in both of our triangles, in the small triangle here and the big triangle here. But because I don't have parallel lines, there is no similar triangles. All right, and that will cover just our basic triangle similarity and building our proof toolkit.